Good afternoon, guys. It's Naveen joining the call. Can you guys hear me?
Yes, sir.
Great. Thank you, buddy. Sorry, I couldn't take the session yesterday. One of my relatives passed away. So sorry about that. So today we'll go into a little bit of an ML scenario, and we will try to understand how ML ops, how we can use the traditional machine learning versus the SageMaker in the ML ops scenario is what we will try to understand. So in order to understand a little bit of machine learning, there are a few concepts we will try to touch. We will not go too deep into it, but we'll try to just get a high level understanding of these things. These are some of the things that will be helpful in especially in an ML world, wherever the ML or the deep learning aspects are coming into the picture. So the first thing that we need to understand is the correlation and the regression. Correlation is used for investigating the relationship between two quantitative variables. Quantitative variables means two variables or two columns or two sets of data where both of them are measurable. In other words, they are numeric in nature. So we'll look at an example of that. Goals of correlation: analyze if the two variables have a relation. This means change in one influences the other measure. So a quick example is the sales of a coffee shop may depend on the temperature. As the temperature is hot and warm, in other words, as the temperature is high, there might be more people coming outside, and they may be going out with their friends having coffee, tea and other things. So as a result of that, sales is increasing. But if the temperature is low, it is cold, people are not coming out of their houses. So if they want tea and coffee, they're making at home. And as a result of that, no sales are happening, or in other words, sales is decreasing. When the temperature is increasing, sales is increasing. When the temperature is decreasing, sales is decreasing. That is an example of correlation. It quantifies the strength of the correlation between the variables. We'll try to understand that. So here is an example of positive correlation. If you take babies, as the age of the babies is increasing, the height of the babies increase. So the age of the babies is on the x-axis is their months, number of months, how old they are in months, and on y-axis we have the height. So as the age of the babies increases, the height is increasing. And here we can also, in a simple way, if we go back to the school, we can say the height and the age are directly proportional to each other. As one is increasing, the other one is increasing. So that is referred as a correlation. That's referred as a more precisely positive correlation. Another quick example is a negative correlation between the temperature and the time babies take to crawl. In other words, when the temperature is hot or warm, or in other words, when the temperature is high, babies take less time to crawl. In other words, when the temperature is high, the time taken is less. When the temperature is low, it is cold. Generally, mothers, they will wrap up their babies in hot clothing, and it is not easy for them to crawl and walk around and things like that. So they take more time to crawl. In other words, when the temperature is more, it is warm and hot, they're taking less time, time is less. Whereas when the temperature is less, the time is more. In other words, a simple mantra is they are inversely proportional to each other. As one is more, the other is less. So we can say they are negatively correlated or inversely proportional is a much more simple way of understanding. So in a traditional machine learning or a data science point of view, positive correlation, this is a visual pattern. On the left-hand side, if the x-axis is increasing, the y-axis is increasing. That is a visual pattern of a positive correlation. The data scientists, when they look at their data, they try to, one of the first things that they try to understand is there any correlation between the two variables? positive correlation. The negative correlation as the x-axis is increasing, y-axis is decreasing. That is referred as a negative correlation. If you do not, if the two variables are not dependent on each other, they are random, at random, irrespective of their values, then that is referred as a zero correlation or a neutral correlation. What is an example? We'll try to understand. So again, use correlation to determine if the students who are good at mathematics tend to be equally good at English. In other words, one moment, guys. Okay, sorry about that. Too much construction work going around our house, guys. So let's say if you take a group of students in a class, imagine a group of students who got good marks in English also got good marks in mathematics, or vice versa. If you, from a mathematical or a statistical point of view, generally, the data scientists or the statisticians will say, in the students who are getting high marks in English are also getting high marks in mathematics. So there is a correlation. But it doesn't mean, maybe in a particular class, we have observed the data indicated that all the students who got good marks in English also got good marks in mathematics or vice versa. But it doesn't mean that if a student, if we go to another class and train the students well in English, they will also get good marks in mathematics. It is not necessarily going to happen. So what is that? That is referred as a causation. Sorry about that, guys. That is referred as a causation, is what it is. In other words, it is not necessary. If it happened that the few students got good marks in English, also got good marks in mathematics, it's probably a coincidence, but you just cannot go outside and tell everybody to learn English well so that they can also get good marks in mathematics. That is referred as a causation. In other words, I'm trying to introduce you to another term or a word called causation is what it is. Okay, so the big mantra in the world of machine learning, AI, data sciences, correlation does not mean causation. So if you go back to the example of the English mark students, statistically, they say there is correlation, but it does not mean causation. Similarly, India loses a match if Sachin hits a century, which means whenever Sachin is hitting a century, India is losing a match. It doesn't mean that if you want India to lose a match, we need to make Sachin hit a century. In other words, imagine there's a match tomorrow between India and maybe England. In the last few games, whenever Sachin was hitting a century, India lost it. So England will never plan in a way where they will think that, hey, if we have to make India lose the game, we need to make Sachin hit a century. They will never come up with a plan. What is that? That is what it means. Correlation does not mean causation. Again, at a slightly high level, there are two terms called correlation and causation. Yes, generally correlation is measured. Positive correlation is a value between 0 and positive 1. Negative correlation is a value between 0 and negative 1. Then comes regression. This is one of the machine learning algorithms we'll try to understand. At least one algorithm, if you have an understanding, all the other algorithms will follow similar steps, and it will help us in understanding some of the development life cycle of the machine learning algorithms, guys. So we'll go. I will try to give you a high level without bogging you much into the technical or the mathematical details. So just bear with me for a few minutes, guys. So the formal definition: it is a statistical process for estimating the relationships among variables. Okay, so it is. The focus is on the relationship between a dependent and one or more independent variables. In other words, there are a few terms which are coming up which we need to simplify and understand. So let's say a traditional machine learning model involves this process. We start with the data, we prepare the data. Preparing the data is also referred as the data cleaning. Then the variables are selected, that is referred as the feature engineering. Then much more deeper analysis is done where a data scientist may build custom variables. Again, that's a little advanced part of it. We'll not go into that one. Then the variables can be further massaged, which is nothing but transformation. Then once the variables are ready, we will try to build a model. Or in other words, the data scientist will try to build a model. So imagine a cricket match. How much a player, maybe Sachin or Dhoni, or maybe all the Indian team players, how much they are scoring may depend on the temperature. How much Sachin is scoring may also depend on many factors. Do they have more left-hand bowlers? Do they have more right-hand bowlers? Is the offside distance more? Is the onside leg side distance more on the stadium? Is the pitch much more close? So we can take many factors like that. And what do? We build a model. The model is used for prediction, which is then validated, which means tested, and then it is deployed. So at a high level, that is what it is. A couple of machine learning algorithms, linear and logistic regression. Then we have in each of them simple versus multiple regressions. So here is what it is. Simple linear regression is generally referred as an equation of line y equals to mx plus c, back to school. M is the slope, and here y is the dependent variable. Imagine you take an example of coffee shop where we are saying the sales of a coffee shop depends on the temperature. In such a case, the sales is referred as a dependent variable. The temperature is referred as an independent variable. The score of a player, maybe Sachin Tendulkar, may also depend on the temperature. It may also depend on many other factors. So in such case, from a data science point, the score of a player can become the dependent variable. The rest of the variables or columns of data are referred as independent variables. Okay. When we take only one variable, that is called simple regression or simple linear regression. So back to the sales of a coffee shop, if we just take the temperature, that is a simple linear regression. But the sales of a coffee shop may also depend whether there's a one-day international match on the day. It depends on the temperature. Is there maybe an award ceremony going on? Is there maybe a new movie, a top movie is getting released? Many other factors like that. In such case, we refer to that as multiple linear regression. Making sense? Are you with me so far, Rahul and Sumit?
Yes, sir.
Okay. So, thank you. So we'll go into a little bit kind of a slightly technical example. Imagine a group of employees in a company. The salary of an employee depends on the experience. From a machine learning standpoint, the dependent variable is generally plotted on a y-axis, and the other factors or the other variables are generally plotted on the x-axis. So here we have salary. Based on the experience of a person, we pay the salary. So we say salary is dependent on experience, salary is referred as dependent variable. So what do? Imagine a group of employees. Each of the red dot or the red mark here is, imagine the salary of an employee. In other words, if you come here, this guy is probably at 30,000 rupees or dollars, and maybe he has 1 year experience. This guy with 2 years experience, his x-axis is more, his y-axis is still less. Maybe that's $25,000. And if you take this guy, maybe this guy has 10 years experience, and he's probably at $100,000 or maybe more than that, roughly. So in other words, these red marks are nothing but the salaries and experience which are represented in a two-dimensional. We are taking data, we're representing them on a two-dimensional axis is what we are doing. What we can do is we can come up with a line like that, and that line, using that line, so imagine how we come up with that line. We'll try to understand that. Imagine we came up with a line which is generally referred as the best fit line. The line meets the y-axis at 30K. So now, based on this one, imagine a new intern or maybe a new employee is joining this company. And let's say he's a fresher. So what does this line tell you? Since the line is meeting the y-axis where x is equal to 0, x equal to 0 means the experience is 0, means a fresher. The line is indicating, based on the line we can interpret and say, for a fresher, we will pay $30,000 is what we can come to or infer. If we apply the same logic to this one, imagine somebody was at 3 years experience, and let's say he's completing 3 years and he's going to the 4th year. So now you can go and ask a project manager how much raise we should give. But the problem with humans is they might be biased. They may like employees, they may not like employees. If they like the employees, they may give too much. If they don't like it, even a good one may not be given. So the problem is bias, and that could create a problem. So what do? That's where we can come back to the mathematics, the story of the mathematics, statistics, and probability. And what does the line now tell you? If somebody is getting promoted, maybe completing 3 to 4 years, what we are doing is we are projecting the 3 year onto this line, the 4th year onto this line, then project it onto the y-axis. And if you notice, it is indicating a difference of 10K, which means it is suggesting, the line is suggesting we can give them a raise of $10,000. So the same logic could be applied. So what is this? This is the story of the line. It is helping us make a business decision. How much should we pay for a fresher versus 3 to 4 years, maybe 4 to 5 years, and things like that, based on what? Based on the data. The data is the genuine data of the salary and the experience of the employees. So what happens is there is no bias or less bias. And if there is less bias, we end up making better decisions. In other words, if you do reverse that, we are making business decisions based on the data. That is what is the objective of the machine learning, to help the business in making better decisions. And what is it? We are using the mathematics here in making decisions, is what it is. So if you go one step deep into this aspect of it, into the algorithm, the line that the black line that we are seeing is the model, is referred as a model in a statistical or a data science world. So the question is, how are we coming up with the line? And the line is generally referred as a fit line or the best fit line, is what is the question. So what we'll try to do is, I'll try to give you a brief understanding of a few mathematical concepts, and generally the other machine learning algorithms will revolve around such kind of concepts. If you have an idea of at least one machine learning algorithm, you'll be able to relate it easily and be able to understand in other operations and things like that. So I'll try to give you a quick touch without bogging you down into technical details. So back to the salary and the experience of a few employees we have taken. And imagine we have somehow come up with, or we have drawn a line, a random line. Now what we do is, imagine you're drawing this manually. That is the first step. The second step is the red mark versus the green mark. What we are doing is, from each of the points we are projecting, we say we are projecting onto the line. When we project onto the line, the green dots touch the black line. Wherever the green dots touch the black line, that's where a green mark is there, a green plus. What is that? That is called a projected point. The red one is the actual point of the actual salary, yi. The green one is the projected or the predicted salary, is what it is referred. So in other words, more precisely, if you let's say take this one, if you think of this as $100,000, the y-axis here is, let's say, $100,000, and let's say this guy is 10 years experience. For somebody with 10 years experience, let's say for the sake of simplicity, we are paying $100,000. Now what is happening is, wherever it is touching the black line, and if you project it here, and let's say this is coming to be $70,000. So what that means is, the line is giving us a projection, or suggesting us that with somebody with 10 years experience, maybe we should be paying $70,000, is what it is indicating. But the actual salary is $100,000. So the difference between both of them is referred as $30,000, is called an error. So in other words, more precisely, this is called the actual salary. The green one is called the predicted salary or the projected salary. The difference between them is called an error. Error in what? Error in projection or prediction is what it is statistically. So what is this? What we do is you calculate this error, you calculate this error, and you calculate the error of all the points. Then what you do, for each of the error, you square it. You square the error, and then you sum up, you come up with a number. We are squaring it so that if there are any negative values, they will be rounded to positive. To remove the negative effect, we square it, and then you sum it. That is, what is this? This is called sum of squares of errors. In a machine learning world, we refer that as sum of squares of errors or residual. It is nothing but error, you square it, and then you sum it. That is called sum of squares of errors or sum of squares of residual. And why is it important? We'll try to understand. Then what we do, not we, or in other words, imagine what we do is, we go back to the original points, you calculate the average of 5. Somewhere it comes here. Now you draw a line at the average of 5. If you draw a line at the average of 5, then you start projecting the points onto the line, and you repeat the same process, which is you calculate the difference between the actual and the projected point. You get some value, that you square it, then you repeat the process, you sum all of them. That is called total sum of squares of total. Now what you do is you apply this formula. This R square is 1 minus SR, SS rest by SS total. So what does this R square tell you? The R square tells you we can draw, let's say we have drawn this as line 1. And let's say we have drawn this as line 2. And let's say we have drawn tens and tens of such lines. What the R square tells you is the line which is closest to all the points is what this R square value will end up. And how do you know that it ends up? Well, that is based on the statistical research. You know, a lot of PhD guys, they come up with this research and things like that. And they say, hey, here is a line which has the highest R square, which means this line is most closest to all the points. In other words, this line is the best line. Statistically, we call that this line as the best line. This line is called the best fit in a statistical or a machine learning world. Imagine in a slightly, to give you another example, each of the red mark here is a characteristic of a girl. And each line is like a boy who's trying to marry this girl. What we would like is, we would like that boy whose characteristics are most similar to the girl. So what do you do? A lot of boys are trying. We're trying to find the best fit. What is that? That is kind of like a friendly mantra of what is called a best fit line. What do you do? Imagine you have to draw 10 or maybe 100 or maybe 1,000 such lines. What is the problem? Well, drawing one line itself requires a lot of time. Okay, calculating all these things manually requires a lot of time, and it almost becomes impossible to find out which line is the best one. What do you do? That's where we use the machines. What do the machines do? That's what the machines are doing. The machines are doing all this stuff. They calculate the sum of squares of errors, the total sum of squares, and then they calculate the R square, and then they give you back the line which is like the best bridegroom, the line which is referred as the best fit line. What is the technical meaning of it? That line is much more closer to all the points on the plot rather than the other lines. So now what do? You take that line and now you take the business decisions. How much should you pay for somebody who's a fresher versus 1 to 2 years versus 2 to 3 years, or maybe 1.5 to 2.5 and things like that? You're making business decisions. So what is happening? That is what is the algorithm doing. The algorithm is performing this kind of mathematics, statistics, and probability techniques. Every algorithm performs this kind of mathematical, statistical, and probability techniques and gives you back some kind of a line. What is a line? The equation of line is y equals to mx plus c if you go back to school. Now, what do? That is referred as a model. Using that model, what do? We can make business decisions. We can make predictions, and we can make business decisions at a slightly high level. There are various ways in which we can optimize, but we don't have to go that far, is what it is. Are you with me so far, Rahul and Sumit?
Yes, sir.
Yeah.
Okay, so in a traditional machine learning world, what do data scientists do? They take their data. So think of maybe a student and a teacher. Imagine teacher has 100 questions. What the teacher is doing is he is dividing the questions into 70 questions. Then he divides them into 30 questions. And imagine a student is given the 70% of the questions and he's asked to study. So here is the student and he's looking at the 70% of the questions. He's trying to understand the concepts in them and he's studying. So what do we do? By the time he's done, he has a picture. He has an understanding. Oops, let's see. So he has created a picture or an understanding of all the concepts, is what it is. So now, what is that? That picture or the understanding that he has in his mind, in his brain, is referred as a statistical model. What do you do then? Then he's being tested. If you have studied well, you understood the concepts well, then here is 30 questions from the similar chapters. What do? You try to answer them. So in other words, the 30% of the questions is given to him. And let's say he scored 27 out of, correctly, 27 out of 30. So what does that mean? That means his accuracy is 90%. What is that? That is how a student is tested. What is the student? Student. And the picture or the paint he is drawing in his mind is what? Is the model. Okay? The student is like the mathematics. The output is like the paint. He's painting in his mind or brain. And that is what is called the model. In other words, what we are doing is from data, we are getting some kind of a model. We are producing. How? Behind the scenes, the mathematics, statistics, and probability concepts are at work in coming out with this model. And then what you're doing is you're testing. If you score maybe 27 out of 30 correctly, your accuracy is 90%. But let's say you scored only 3 out of 30, that is 10%. And what is that? That's not a good preparation. That is not a good model. Your accuracy needs to be as high as possible. If your accuracy is high, if you score well on these 30 questions, then you have understood the concept well, which means your model is well. If your model is well, you deploy it. You test it and you deploy it. You deploy it on new. So in other words, you're being sent to the final exam. If you don't study well, you're not being sent to the final exam. In other words, why is this important? This is referred as supervised learning. What is supervision? The student is given 70% of the questions. And imagine he is also being explained. So he's being supervised so that he can answer his test well. That is referred as supervised learning. In unsupervised learning, the data is not split. The data is the model. The model. So another example of unsupervised learning is, imagine there is a teacher who teaches maybe maths, physics, and chemistry. And let's say he has a few questions and answers. They're all mixed up. Now he comes to a student and says, hey buddy, please help me in separating all the maths questions, physics questions, and chemistry questions separately. And imagine a student is helping him. He helps him, he separates them successfully and gives saying that, hey, here is the maths questions, here is the physics, here is the chemistry questions. So what is that? Here, a student is not being tested. He is not being separated, split the questions into 70 and 30. He's given the entire data. The questions are, and the answers are the entire data. He's just simply separating. What is it? There is no splitting. What is it? That is unsupervised learning. The objective of unsupervised learning is finding hidden patterns. A group of math questions, a group of physics questions, a group of chemistry related questions are examples of patterns. That is called unsupervised learning, guys. Okay. So here is a quick example of some data. Imagine a scenario, going one step deep here, guys. A profit of a company may depend on the research and department, their research and development. It may depend on the administration costs of the spend, how much they're spending on their chairs, tables, and things like that. It may also depend on marketing. How much you? So among these three, which one do you think is the most important thing, guys? Sumit or Rahul? The profit of a company, which one do you think will depend mostly on?
On R&D, sir.
On R&D, and why do you think so?
Because they can get more profit with the new innovation.
Okay, so in other words, short and sweet. I mean, it can also depend on the marketing. It is not a guarantee that it's always R&D or it is always marketing. It can also depend on state. But most of the time in R&D, there is more innovation, more creativity, more innovativity happening. The more the creativity and innovativity in a company, the more the chances of progress is what it is. This is one. What is this? This is logical thinking. This is our thinking. That is what is called hypothesis in a statistical world. That is what data scientists do. They're constantly thinking. So the green color indicates it's a dependent variable. And the blue colors oops, will generate more revenue. Okay, good one. Okay, the blue colors represent they are independent variables. And R&D can exist by itself. It may not necessarily depend on others. Administration, marketing may also can also exist independently. Whereas profit generally depends on something or the other. So we are treating profit as a dependent variable. And it can also depend on the state. Maybe in some state the taxes are more versus in some state taxes are less. Is also an important factor. So the green is dependent and the blues are all the independent variables is what it is from a statistical point of view. Now what is happening is the state is in textual data, whereas the rest of the columns are in numerical data. If we want our models, if we want to build a model which is generally dependent on the mathematics, statistics, and probability, we cannot use textual data. Okay, so what do? In such a case, we take the textual data and we convert it into numerical data. So what do we do for the New York and California? We create separate columns. Wherever there is a New York, we put a 1. And wherever there's no New York, we put a 0. Repeat the same process with the California. So what have we done? We have now converted textual data into numerical data. What is this? This is just a statistical principle that we are following. It is not a perfect method, but generally the statisticians or the data scientists follow this process to convert the textual data to numerical data. And then what do? They remove the textual data. And they call this new numerical columns as the dummy variables. The data was not there, but now they have created, so they're calling it as dummy variables. So generally the process is, if there's New York and California, then the mantra is n-1. You don't need 2 columns. To understand whether a row is New York or California, you just need 1 column. So the mantra is always omit 1 variable is what is the mantra. So building a model is generally, Y is the dependent variable, X is independent variable. You may have many other variables. What is important is an understanding which variable is important. The sales of a coffee shop may depend on the temperature, may depend on if there's a game in a nearby stadium, because if there is a game in a nearby stadium, a lot of people are passing by, and before they get into the stadium, maybe they like to have a coffee, and as a result of that, the coffee sales may increase. But remember, the sales of a coffee shop will not depend on the phone number or the building number or the door number of the coffee shop. What is that? Those are the kind of data or the variables we need to remove. What do? That's how a model is built. Garbage in is garbage out. If you use that kind of data in building a model, that is not a good model. That will not do a good job in making predictions correctly. So that is what the data scientists generally do. That is a little bit of the statistical process and a little bit of mathematics of machine learning algorithm, guys. Okay, now what we'll do is we'll try to quickly build a model and try to get a feel of it. Rahul, can you share your screen, please? We'll get into SageMaker.
Yeah.
In the console, just type in SageMaker. Okay. And let's say, yeah, get started. No, we don't need to set up the domain. On the left-hand side, you see something called a notebook. Expand the notebook on the left-hand side.
Okay.
Notebook instances. Create a notebook instance. Just type in NB2. T2 medium is okay. And scroll down. I think you can leave the default. Okay, we have created an execution role is already created. Okay, yeah. Just go ahead and create it. And let's say NB2 pending. Okay, let's give it a moment here.
So what we are going to deploy in this?
NB2. We'll try to understand what needs to be deployed here.
So we will create one model here.
Yeah. We'll create a model in SageMaker.
And that will be we will use for prediction of for something.
True. Once we create a model, that is generally what is deployed. And the process of creating the model, which is generally, before you create a model, you do a lot of data pre-processing and wrangling. That is generally code-driven. Code-driven, which is like your traditional code base and application. The model itself is a skeleton of the data. So many times in your deployment operation, sometimes you may just need to refresh the model versus refresh the pre-processing part of it. So that is what you need to understand. You need to have a slight idea of what it needs to refresh a model. A new model is or versus a or not.
Okay.
It should take a minute here. Click on NB2. Still says pending. Just give it a moment.
So what is this notebook instance?
This is all the Jupyter. This is where we create the Jupyter notebooks. Earlier we created the Jupyter notebook and we learned Python, right?
Yes.
It is nothing but the same Jupyter notebook, but the notebook is sitting on the cloud rather than your local box.
Okay.
This is the Jupyter on the cloud is what you can Amazon solution for Jupyter on the cloud.
And here are the other options also. Training, interpreting,
yeah,
augmented.
Yeah, those are all separate these things by themselves, buddy.
Okay.
For example, the augmented AI is nothing but all the the AI related stuff, and Edge Manager is the IoT related stuff, and expand inference. I think these are some endpoint related. Endpoint related means some of the models are built and they can be exposed as microservices. Some of them also make them available as commercial. You can buy them rather than building your own models and things like that. I think those things are provided here. We don't need all those things for this one.
Okay.
I think training is generally just a training stuff and so on. Yeah, let's give a moment here. Take a short 5-minute break, Rahul.
Yeah. Okay.
Thank you. I'm back, Rahul, just in case you're back.
Yes, sir, I'm also.
Okay. Click on maybe Open Jupyter Lab. Okay, this is, it's just, you can select conda underscore Python 3. That is nothing but we're going to use Python 3. In the third row, first one, first cell. Okay, if you just type in 1 plus 1, shift enter. As simple as that. This is just like a regular Jupyter notebook, but I will upload one file in the drive. If you access the drive, give me one moment here. I'm right now uploading it. Okay, I have uploaded a file called salary.csv. If you refresh the screen. The last one, yeah. Download the file. Then go back to SageMaker. If you see on the left-hand side, there's a plus, no, on the left-hand side. Yeah, right there, yeah. Click on that. Oh, no. Let's see. Close that and upload the one by the right side of it. And now choose your file. Okay, so if you just double click on salary.csv. So this is an example of a data file. We have years in experience and salary and roughly around 30 records of data. So the first guy has 1.1 years experience and $39,000. And if you scroll down, notice the permutations and combinations of the years and experience and the salary. Some may have less experience and they may get more salary. Some may have less experience and they may have less salary. And other kinds of permutations and combinations are possible. So it is not always easy to understand the patterns in this one. So what we'll try to do is imagine, based on this data, if a new employee is going to be joining a company, we can try to predict what his salary is going to be. Ideally, in a real world, you may have different kinds of data. The data will be different, but the concept will be same for a data scientist. So if you know how to drive one car, you can drive all the cars, is one way to think of it. So go back to your, click on the untitled, yeah. And here, I will show you a few steps. I will paste a few steps here. Okay, let's say we'll start with importing a few libraries. Let's say paste this once inside the cell and shift enter. Try to paste.
Where I got this error.
Yeah, try to paste. Yeah, we need to install TensorFlow package.
Okay.
So paste these two lines on the top of those imports. And shift enter. So generally, if you're in a command line, you do a pip install. If you're in Jupyter Notebook, you need to put that exclamation. Just increase the size of your font, Rahul. Enough, good enough. Scroll up, please. Still working. If you have a star, it's still working, if you recall. So back to a little bit of Python here. Just an FYI. So it's installing a package called TensorFlow. TensorFlow is a deep learning package from Google, open source deep learning package. We don't need to go into those details, but syntactically we will touch it. And once that is done, we can read our file. If you still remember the data frames bd read CSV, here is the next one. Scroll down, please. Okay, paste this one that I sent you. Salary df bd read CSV. Shift enter. And now just type in salary underscore df. So there it is. It is reading the data in the form of a data frame, if you recall. We briefly discussed about the data frames and things like that.
Yes.
And if you just say salary df dot head, it will give you the top file. Type in salary df head. Head in brackets. So the top 5 rows, tail will give you the last 5 rows. But let's see. Let's try this one. Here is the next one. So imagine you're a data scientist for a moment. Generally, this is what you do with this kind of data. Try to execute the heat map. So here heat map is nothing but a function in a library called SNS, which is nothing but Seaborn library. If you recall, Matplotlib is the one visualization package we briefly discussed earlier. So Seaborn is like a much more advanced package than Matplotlib.
So heat map is same as Matplotlib, right?
Nobody. Heat map is a function in Seaborn. Matplotlib also has its own heat map. And that probably has a slightly different name. So Matplotlib is like a SNS or Seaborn library.
Okay.
And here, what we're doing is salary df. In that data frame is null means or any of the values null. So basically, a data scientist is checking to see if there are any null values. Null values are corrupted data. They want to get rid of any of them. So notice both of them, years in experience and salary, do not have any bars, which means there are no null values here, is what it really means. A little bit deep, but it will be helpful. This is what is called data cleaning. Data cleaning is you're removing any of the corrupted data. And here's the next one. Execute the info. Again, looking a little bit deep into the data frame, there are 35 rows. These are the column names. Non-null is 35 and 35, which means there is no missing data, no corrupted data. And the data types are this one. So this is just trying to understand the metadata. Then do a describe. And if you do a describe, scroll down. So if you look at years of experience, it's indicating the minimum, the employee with the minimum experience is 1.1 years. The one with the maximum years of experience is 13.5. Mean is 6.3 years. On an average, all the employees have around 6 years experience. Salaries minimum is $37,000 roughly. Maximum is $139,000. On an average, $83,000 or $84,000 is the mean. Is kind of, you know, some insights that a data scientist is generally trying to understand and get a feel of the data. These are some of the things that they look into it. Okay. Then let's say, try this one. Try this one.
Yeah.
Okay, what do you think that is?
It is the maximum salary.
As simple as that. So the guy with the maximum salary, if you need to change that to min, what do you do?
This function needs to be changed to
Good, as simple as that. So in other words, this is called exploration. That is what is formally referred as exploratory data analysis. So in other words, in times when you're interacting with an ML team, or maybe you're interacting with a data scientist and things like that, so they might throw these words at you. Hey, this is exploratory analysis. It is also referred as EDA, exploratory data analysis, and things like that. These are some basic things of EDA which we need to be aware of. Okay. Then let's say, okay, a little bit more exploration. Here we go. Try this one. Okay. Now, if you look at the red bars on the left-hand side, you have years experience. Take a look at the top two red bars. They're touching at 3. And if you scroll down on that one, this is what it is telling is there are 3 employees who have there are 3 employees who have experience of 1 year. There are 3 employees who have experience of, what is this one? Scroll down, please. 4 years, roughly. And if you take a look at the rightmost bar between 12 and 14, that is how many? There is 1 employee who has experience between 12 to 14. So kind of interpreting a bar chart is what it is. What are we doing? This is called exploration, trying to get a little bit deep, trying to understand it. Trying to understand is what is referred as trying to understand the insights in the data. And when they are understanding the insights in the data, they might run into many issues. They may not have the data. They are probably not seeing the data and things like that. Those are some of the things that you might come across from an operations standpoint is what it is. Okay. And let's say, okay. Let's have here. Let's say, I think just try the next one, please. The correlation, there you go. So here, the 0.98 between, if you look at the first cell from the lower side, salary and years of experience, 0.98. If it is close to 1, what it means is it has a high correlation. The high correlation is positive. That means they're directly proportional to each other. Here, the salary 0.98 means as the experience is high, the salary is high. Can you think of reason why when the experience is high, the salary is high? Rahul? Why are we paying more to the guys with more experience? Simple answer, it's experience. Nothing can beat experience.
Yes, yes.
No matter what degrees you have, if you don't have the experience, if you have the experience, you know it. If you know it, you have the knowledge. More experience is generally mapped to more knowledge, right?
Yes, yes.
So that's why whenever the experience is more, people are getting high. Salaries is what it is indicating. The higher that value is, that means that is more dependent on the experience. Imagine that was like 0.18. That means the salary and experience are not dependent, or the salary is not dependent much on experience, is what it means. Catching it? If
Yes,
it
yes.
is negative, that means it is reverse. As your experience is more, your salary is less. If it is negative, what is this? This is a data scientist or an ML engineer's way of understanding, looking at the data and trying to come at some conclusions. Okay, so like
Yes.
that, there will be many things, but let's say now, let's try to build a model. So here is, let's say, try this one. Okay, let's see, here's a, see if you can, okay, try this one. What do you think it is?
Is years of experience.
Column, as simple as that, or variable. Similarly, here is the next one. Try this one. Okay, what do you think this is?
No, this is salary column.
Simple as that, salary column. Try the next one. Okay, so what do you think is this one?
This is the 35 rows and one column.
Simple as that.
That's
That's what is shape. And let's say, okay, try 1 second. Opens. Okay, try this one. Okay, can you take a guess what is happening here?
We are creating array of elements.
So in other words, this is an array of arrays. More precisely, it's a tray of trays. It's two-dimensional data. So generally, in SageMaker, it requires two-dimensional data. Single dimension, an array is generally converted to a two-dimensional data because SageMaker internally uses TensorFlow. TensorFlow requires this additional dimension of data, something to be kept in mind. Okay. Now,
Yeah.
similarly, we will also repeat that for Y here. Try that, please. Okay. So X and Y. So what is X? X is years in experience. Y is nothing but the salary. So in other words, in a machine learning world, generally the Y is the dependent variable. Salary depends on experience. So X is the experience is what it is. Now try this one. So in other words, we are separating the dependent variable and the independent variable is the first step, or is one step to build a model. First step to build a model. And so now what is happening is, imagine a teacher and a student. A teacher has, let us say, 100 questions and 100 answers. X is all the questions, Y is all the answers. Answers depend on the question is let us say, for the sake of simplicity. What is test size 0.2? Imagine the teacher is saying, I'm going to split this data, train, test, split. The mantra of that is splitting. He's splitting the data into 80 questions and answers. 20 questions and answers. So that is what train test split is. Train X test is going to be 80% of the questions, 80% of the answers. Y train Y test is, I'm sorry, X train X test is 80 questions, 20 questions. Y train Y test is 80 answers, 80% of the answers and 20% of the answers. Are you with me, Rahul?
Yeah, so in X there is 80% data, and in X train there is 80% data, and X test there is 20% data.
True.
Okay.
That understanding is important, Rahul. It will be useful for you.
Yeah.
So next, what we'll do is we'll actually build a model here. For that, we'll first see a traditional machine learning algorithm, and then we'll see what is called a SageMaker. So let's say, here we go. This is the traditional machine learning, which is scikit-learn. Run this, please. Okay, so here what we are doing is we are creating an object of linear regression. What is linear regression? We just discussed the story of a bride and a bridegroom. We're trying to choose the best bridegroom. Mathematically, the best bridegroom is the best line. The best line is referred as the best fit. The best fit is the best fit line. In a statistical world, they refer that as the best fit line. Linear regression, when you create a linear regression object, what it does is it will do all the steps. Trying to do 10 or 100 steps by manually, it is almost not meaningful. People will run away from that kind of jobs. That's what the algorithms do. So once you create an object, then here is the next one. This is the one which is actually building a model. When you say fit, okay, so now when you say fit, that is a trigger point. The process in a Python machine learning world is you first create an object of algorithm. That algorithm can be any name. It can be a random forest regressor, decision tree regressor, or many other regressors are there, XGBoost and so on. The concept is same, but the data will be different. Here, instead of salaries and employee organizations data, you can give healthcare data, you can give medical data, telecom data, or you can give stock market data. The data will be different, but the concept will be same as what is the mantra. When you say fit, that's when the algorithm is at work. The algorithm is doing its mathematics, statistics, and probability. It's applying those concepts behind the scenes. And now the object becomes the model. The object is referred as a model that is capable of predicting. So what we'll do?
This object, this is an object linear regression.
Yeah. That is the object which is now has become a model. In other words, when you first say linear regression, when you first create an object, you're calling the student. You're calling the student. When you say fit, right? The X train is 80% of the questions and Y train is 80% of the answers. So the teacher is giving, here is 80% of the questions and the answers you study. And when the fit is like study. Study is where he's understanding the concept. He's being supervised. He's painting a paint in his mind and brain. Okay. That paint is called the model. Okay. Now on the next one. Minus 1.79. Oh, okay. We got a very holy cow, we're getting a very negative one. Okay, that's not a good one. This is not a good example of accuracy. Generally, it is much more close to 1. The more close to 1 it is, let's say, just for sake of simplicity, scroll up a little bit. In 20, from 20, run again every step up to there, all the below steps, shift enter, shift enter, shift enter, up to the accuracy. So every time a different random number of questions are taken. 0.96, goodness gracious. Okay, sorry about that. -1 is generally very low. It should be, it's generally, should be the much closer it is to 1, the much better it is. So every time you do a train test split, what is happening is a random 80% of the questions are being taken. And when you are saying score here in this last line, What is that method doing? That method is taking 20% of the questions and it is taking 20% of the answers, and it is internally comparing the predictions. It is making a prediction and comparing how close its predictions are is what it is. I'll see if I can help you simplify that one with me. But let's say try this one. Let's try the next one.
So here we have created the model already. So here we are comparing with using this test data, right?
Here, more precisely, we are comparing our actual predictions with y_ test. X_ test is the 20% of the questions. It is predicting the on the X_ test. Then the predicted results are being compared to y_ test, and there is a 96% similarity. It is 96% close. It's kind of what it is. The 0.96 is. So that is R square. The much higher, the better it is. And if you now look at this, slope is B is intercept, M is slope, which means 8,800 for every 1 year increase in experience. The salary is increasing by $8,800 is what it can be interpreted. That is what is the story of the algorithm. It looks like it is suggesting for every 1 year increase, the salary seems to be increasing close to $8,800 is what can be inferred. That is the insight. Catching it, Rahul?
Yes, sir.
So now, let's say here is the predict. Let's say come here. Okay, try this one. This is the predict. So these are the predicted, only 20% of the questions. What is this 20% of the questions which we have hidden from the student? These are the answers he has given. Now, if you just type in y_ test in the next one, in the next line, not there, but in the next line, yeah, just type in y_ test. No, just y_ test. Remove the entire.
Okay.
So notice y_ test is actual $126,000 is the salary that is being earned by that employee. Our prediction has predicted 129, which means it is close. It is not too far away. If your prediction is too far away, that's a bad model. So next again, the next one is 105, which is the actual below, and the predicted score is 107, which is again closer. So here, like this, we can manually compare this one. The difference between these two is called the error. Let's see if I'm calculating the error here. And let's say, instead of manually looking at each one, ideally, what we'll do is regression, predict, and extend. Let's say, copy this one. Try this one, please. Okay, so here is the line, the red line. This is the best fit line, and this is the salary. And let's see what we are doing here. We have given, if you look at the code, we are doing a scatter of X train and Y train. Plot is X train and predict.
Yes.
Salary and number of years of experience is what it is. So a scatter. So this is for the salary versus years. So here we're showing the model here, but let's say, okay. So in other words, we're just drawing a line here. We're just giving it in a red color is what it is. How the what is the best line is what we are showing here. Is what it is. But what is this one? This is the traditional machine learning library or the package called scikit-learn. If you scroll up a little bit, where you have created the here. So notice sklearn is scikit-learn package. Traditionally, most of the guys who are not into AWS and they're doing machine learning, they use this package. But in AWS, we use SageMaker. The same steps will perform with the SageMaker. So let's see, do a few imports. Okay, run this one. Then run this one. This one. I'll explain this to you in a moment. Then run this one. Okay, so what is happening here is, if you scroll up a little bit, in SageMaker, you're just importing the SageMaker. Boto3 is nothing but a package for Python in AWS, using Python in AWS, and you're importing a session. So in other words, we start a session. This is generally the syntactical process that they follow. Then here is where we are saying we're going to be using a bucket, and has 3 bucket in a moment. And prefix is linear learner. What we are calling as linear regression algorithm. In a SageMaker world, they call it as linear learner. In another package, it might be called a slightly different name, but that is what the prefix is. Then role is generally to access any of the buckets in S3, we need to create a role. That is what this is doing. Okay, what we do manually on console, the data scientists are doing in a code is what you can think. Then come here. I think we need to do a little bit of slicing and dicing here for SageMaker. Run this one. Okay, then run this one. Okay, so here, what's happening is 28 rows. Roughly while underscore train is 28 rows of data is what it is creating, and doesn't look, it just looks like it's a straight 28 rows. Okay, next import IO. We also need to import a couple of things. Then import this one. Okay, so this whole process, you might be thinking why we are doing all this one if you kind of think of from a general traditional development standpoint, this is like developing an application. This whole Jupyter application is like Jupyter code is like one application a developer is developing. Later, we will try to deploy it. What parts need to be deployed is where we need to have an understanding is what it is. Okay.
Okay.
This is the next one. So these are a few common imports that we generally need to do in SageMaker. Okay, so buffer. So bytes IO is just a byte array. Generally, the data when it is traveling in the network and things like that, it is traveling in the form of byte arrays. That's what the first step is. Then here, write NumPy to dense tensor. Again, that's a slightly deep learning terminology. But the byte array, whatever is in the arrays of Xtrain and Bytrain is being converted to byte array. That's what that step is doing. Buffer.seek, again, we need to manually put that cursor back there. Is what it is. Next, let's say copy this one. Use this one. It's for training. Yeah, import OS. I think this is right. Okay, try this one, please. Okay. So then try this one.
We got this error.
Yeah, warning is okay, no problem. Okay, so what is this one? This, at this line, the above two cells, what they have done is we created a bucket called linear learner in S3. Under that, there's a folder called train. Under that, there's a linear train data. So open in a new tab, open S3. So in SageMaker, we are programmatically doing all these steps, what we generally do at a console level. Go to S3 and I think what is it? Linear learner, I think is, are you in S3, buddy?
Yes.
LINEAR. And you're in US East, huh? I think it said something like.
Yeah, it is a global service, so it doesn't matter.
Go back to that notebook. Jupyter Lab.
Yeah.
And it's in SageMaker US East one. Linear underscore learner. What do we do? Oh, sorry. I think we need to create the bucket first. We need to create that bucket linear underscore learner first. Sorry, Rahul. And then it will create the train and the linear train data. So in S3, create a bucket called linear underscore learner. Exact name. That's it. I think it's an East one, isn't it? Yeah. Everything else should be okay. Yeah. Good. 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 No. Keep it. That's okay. Create bucket. Contains invalid characters. Really? I just added 2. It's not allowing hyphen. Strange.
Hyphen allowing, but it is already taken by someone.
Yeah, just added 2 there. Linear underscore learner 2. And now create bucket. Click on that. So it's right now empty. Now go back to the code and just we need to change that linear underscore learner. Where is it coming? It's coming from prefix, I think. So linear train. Scroll up, please. Prefix. Find where is prefix. Scroll up. Prefix. Change this to linear underscore learner. Execute this one. Learner 2. Good. And execute this 2. Execute this. Now come back down. Scroll up. Scroll up. Wait. Here. Execute the cell 41. Value error. Scroll down. What's the error say? Go below the error. Keep all the way down to the error. IO operation on closed file. Scroll up, please. Linear train data, Boto, free resource. We're using the prefix here. Was to join train upload file object. So we change the prefix. Go back to where you had prefix, Rahul. So here's the prefix, and what we need to do is
It is saying prefix is the folder within the bucket.
pardon me?
Prefix is the folder, subfolder within the bucket.
Good one there. So let's say, so what did we do? We have given the upper one as the default bucket. In default bucket, we have to give, in default bucket, we have given prefix linear underscore learner 2. Scroll down, and here is prefix. 1 second. In the default bucket, it is looking for, oops, 1 second.
Maybe it is searching, the bucket name should be this. The
Key.
bucket
So
name should be.
Wait, we are joining prefixes linear to keys linear data, linear train data.
Is there any variable with the name bucket here?
Bucket is default bucket. Scroll up. Scroll up. Yeah, so that is default bucket, which is the root. Under that one, we are creating prefix linear hyphen learner 2. And let's say, then we did a get do one thing. Execute the 35, cell 35. And scroll down. That's okay, common okay. Scroll down, keep scrolling down. Just creating, wait. Now what we'll do, we have written the buffer is ready. Go to, are we passing the role here? We're not passing the role, we're just saying. One more time, execute the cell 44, linear train data, keys linear train data. So Boto 3, Impoto is Boto 3, okay, Anaconda, scroll, it's very strange. From what I recall, this should create under linear hyphen trainer learner 2, it should create a train. Under train, it should create linear train data, which is nothing but the training data, which is 80% of the data is what it should do. So scroll down, please, slightly. It worked when I did it. So, why did it work? So there is a bucket. Bucket is going to be default, and you have prefix and the key. Then you have the prefix is going to be there. Train is going to be the middle one, and key is going to be linear train data. So the bucket is going to go into the first placeholder. Prefix is going to go into the second placeholder, which is nothing but the.
The bucket name is SageMaker. This is the name of that bucket.
Yeah.
So it must be created here. Yeah, it is there.
Is there?
Yes.
Click on that. Is it the same one? Can you double check?
Yeah, it is that here you can see.
It is.
Uploaded tearing that data to you.
Then what was the problem? Why did we?
But here it is giving this error. I don't know.
No. Go back to the S3 bucket.
Yeah, in this S3 bucket, there is a linear learner folder.
Yeah.
Inside that, there is a this many data.
I think this is probably. Try deleting this one, please. The bucket.
This bucket. Okay.
22661, right?
Yeah. One minute. Yeah, 2266.
No, which we created them, but why did we even go back? That is strange. Okay. So it automatically created if it is not there. We didn't even have to create one, is what it is. Okay. So what we'll do, delete the bucket. Oh, shoot, man.
But it won't allow us to empty this bucket. 1 minute.
Yeah, so permanently. Strange. Okay, so now come back to, oh, okay.
Yeah, got it.
Okay, come back to the code and change that back to linear underscore learner, the prefix, linear underscore learner, and execute that. And let's say scroll down to, let's say, yeah, create this one again, execute, scroll down. Value IO operation on a closed file. Let's see.
Or should I execute each step from here again?
Yeah. So sorry, yeah. Try that. This. Sorry about that. Too many. We've already done this, so you need to execute it right from beginning again.
From where?
Let's say where you have trained the split. Here, 24. Execute 24. You don't need 25 because we are directly heading to SageMaker. So scroll down. Scatter. Wait. Here. Sorry. Execute that. Execute. Good.
Yeah, I this time done.
Again, it created the same bucket. Huh?
Yeah, it created. Yeah, this one is the bucket.
Create that. So it took the default bucket as that one. Huh?
Yeah, it created by default one bucket, and inside this bucket, it must upload this.
Upload it and data.
Yeah, here in this train, inside the train there is linear train data. Inside this.
And let's say enable bucket, and I think this is the data. If we click on download, then I think we will get the 80% of the data. Click on that. Open that.
How should I open?
Notepad or maybe a text pad. I think it should stay saving as the binary file. Go back to that one. Go back to the screen. Let's see. Object actions open, and I think somewhere here. Go to the properties. I think maybe it serialize the data here. We should be able to check to linear train data. It's, I think storing in a binary format is what it is, but we will come back to that one. Where were you? You're at S3 train data. S3 train data. Smack, right? Can you, let's see, format S3 train. Should be here, right? It is where it is, okay. Then we will not worry about the shape here. Y_scope test, we'll slice that. And repeat the same thing for Y_scope test. So let's copy this one. Let's go to chart. Oops, one more time. Paste it here. Okay. Repeat the same. This time we're doing it for Y_scope test. And uploading the test data, and we'll print it. The next one is printing it and then go back to bucket and verify. Linear test data, okay. Now go back to bucket, just verify it. Test, click on test. Test, so this should be the 20% of the data. Click on that. Okay, as simple as that. Next, let's say I think we also need to create an output. That's output. Okay. And here is next one. We're going to containerize it. This will containerize it in SageMaker. Region name linear learner. It's getting an image URI. And SageMaker. Okay, you containerized it and so C default. The method has been renamed to SageMaker. Okay. Wow. Next one, have you run the set it? Yeah. Okay. So let's say, have you run that?
Yes, yes.
Okay. Now, okay, this is the one which will take some time, and that's where I wanted to explain. So here we go. Fit this. Okay, so this one will take anywhere from 5 to 10 minutes, I think. Now, if you scroll up a little bit, what we did in scikit-learn in the 3 or 4 lines earlier is what is happening. Scroll here. So first, we are containerizing it. This is how programmatically they are containerizing this one. Inside this container, estimator. Estimator means for regression. regressions, they use this estimator. They're using C4.xlarge, that is okay. And they're passing the row in a C4 xlarge, and let's say scroll down. Set hyperparameters means this is where internally a lot of permutations and combinations of different models are getting created internally. SageMaker is creating different permutations and combinations of model, and on every model it is going to test which one is going to give a higher accuracy. So in other words, earlier when we used scikit-learn, we just created one model. But when we say set hyperparameters, this is where it is going to create different permutations and combinations. So the epochs, mini batch size, all this is deep learning terminology. Will not go into this one, but ideally what I'm trying to convey is data scientist is kind of running, building tens and hundreds and thousands of models like this at one, in order to decide which one is the best model. Out of these hundreds or maybe thousands of models, the best model will be taken up, and then it will be used for prediction. So the fit is where the trigger point is. That's where it's getting triggered. And now it is creating a new xlarge. Everything is happening programmatically. This might take some time here. And then we need to deploy this one. Okay, so what we'll do, you let this run today, Rahul. Tomorrow, we'll deploy this, and if time permits, I'm trying to work on one example. We'll try to test it out on Lambda. Okay.
Okay.
So you let this.
So this is the last example for SageMaker, right?
Yeah.
Okay.
True.
So tomorrow we will do that Lambda function and code will.
True. That's what I'm working on.
Okay.
Okay. Okay, Rahul. For today, I'll stop it here, and we'll continue from here tomorrow.
Okay, sir. Thank you.
Yeah.
Bye.
Thank you, Sumit. Thank you, Amira. Bye.